Hello everyone. First of all, I'd like to thank Hioki Singapore for sending me a unit of the Hioki DT4261 True RMS wireless ready digital multimeter and the Hioki Z3210 Wireless Adapter for review. In this video, I will attempt to explain the wireless functionality of the DT4261 and the Z3210. Now, I'm not here to hype this wireless thing, but I've come to appreciate that this feature is one of the main innovations, if not the best innovation that Hioki designed into the DT4261 when paired with the Z3210. What is this wireless thing and how does it work? There are two ways. First, through a software application called the Human Interface Device Functionality Direct Input to Excel, and the other through an app called Gennect Cross. In this video, however, I will only focus on the HID functionality. I will treat the Gennect Cross app in a separate video. The Human Interface Device HID Direct Input to Excel functionality is a rather long technical term, so from here on, I'll simply refer to this as HID. But in plain language, what is it really? HID is simply a way to transfer data from your multimeter to a Microsoft Excel spreadsheet without using cables. That's it. Wireless transfer of measuring results, be it voltage or resistance, or any other value from your DT4261 to a spreadsheet in your computer or smartphone or tablet. That's about it. That's what HID is to me. If you know of any other meaning of HID, please let me know in the comments below. Incidentally, Google Sheets will also work, not just Microsoft Excel, as I will show you later. Now that we have a notion of what HID does, let's see how we can appreciate its potential use. Let's get started. First, ensure that the DT4261 is powered off. Next, install the Z3210 Wireless Adapter inside the DT4261. This is the slot for the Z3210 covered with a protective rubber cover. Note the nuts on the Z3210 and it must correspond to the protrusion inside the slot there in order to properly orient the wireless adapter. Press gently. Close the battery compartment cover. Using only a coin, we can lock the cover in place. Next, check that the wireless adapter is detected by the multimeter. Turn the power on. And we know that it is detected because the symbol for the wireless adapter is blinking on the upper left corner of the LCD. The wireless adapter can be toggled on and off by pressing and holding the backlight button. Next, remember these two power-up options. Number 1, range button plus power on selector to the ohms position. This will verify the present status of the DT4261's HID. Press the range button and power up the device with the selector pointing to the ohms position. Notice HID on. HID on means that the human interface device wireless functionality is enabled. Return the function selector to the off position. And the other power-up option is this. Range button plus backlight. Press them together and turn the selector to any position. This power-up option will switch the HID status to either on or off. Remember the Gennect Cross app that I mentioned earlier. It cannot be used at the same time as the HID functionality, so we need to switch the HID to off position in order to use the Gennect Cross app. Let's try that power-up option. Press range together with the backlight button and turn the selector to any position. AutoHold is good enough. Set HID off. Now the human interface device functionality is disabled and the screen automatically turns off. Let's put back the selector to the off position. Since in this video we will focus only on the HID functionality, we will turn back the HID to enabled status. Press range and backlight together and power on the device. Set HID on. So the human interface device functionality is back to enabled status. Notice that the screen automatically turns itself off. We will just return the selector to the off position. Next, let's get the laptop ready. In my Windows 10 laptop, this is the Bluetooth and other device settings. First, turn on the DT4261. If the laptop does not automatically detect the Z3210, click this button. Now the laptop has detected the Z3210. Click Connect. Notice that the pin numbers are the same. And we're now ready for the wireless data transfer. To demonstrate the direct Excel input of the HID functionality, I opened a blank Excel file. Now when I watch the promotional videos of the Hioki HID, I often wondered where did their Excel file come from. It seems to mysteriously appear from out of nowhere, completely formatted and tabulated. After exploring, I discovered that you, the user, have to create this Excel file yourself. But don't worry because this is easy. In this empty Excel file worksheet, I have preformatted these blank cells here so that we can clearly see the characters for this demonstration. The DT4261 is now connected to a voltage source. Now watch as I press the hold button. The data from the screen of the DT4261, which reads 226.4 volts, 60.09 Hz, was wirelessly and automatically transferred to the blank Excel file worksheet. Let's try that again. So notice how the values were aligned, including the symbols for the units for both voltage and frequency. They were automatically transferred to the Excel file worksheet by just pressing the hold button. Now if I was working alone, it's quite awkward to hold the test leads with both hands and at the same time press the hold button. This is where the AutoHold feature of the DT4261 comes in handy. Let's try that. First test point. Second. Third. Although Hioki mentions that HID works with direct input to Microsoft Excel, I experimented and discovered that the HID will work just as well with Google Sheets. Let me show you. I'll open a Google Sheet file that I have previously preformatted. Since I know how the data transfer work wirelessly, I created and preformatted a worksheet to demonstrate how this can be applied to a particular scenario. Here is an example of the Google worksheet that I prepared. This is just a simulation of a three-phase supply to illustrate the HID. I will test using my AC demo boards, mini circuit breakers, and also use the AutoHold function of the DT4261. Notice how the HID follows the worksheet format. First test point. Second test point, VBC. And third test point, VCA. Let me give you another example, this time a resistor table. Turning my selector to the resistor test function, I will still use the auto range and AutoHold. Resistor number 1, 10.1 ohms. Number 2, 100.7 ohms. Number 3, 464 ohms. Number 4, 9.84 kilo ohms. It even knows how to affix the K in kilo ohms. Number 5, 66.7 kilo ohms, and the last one, 0.682 mega ohms. And to cap off these simulations, a DC voltage test. I will turn my selector to the AutoVolt function, but toggle the function button so that I can only use the DC voltage function, still using AutoHold. But now I'm going to change to manual range of 60 volts DC. 9.09 volts with reverse polarity. $8.84 volts. Minus 7.2 volts. Let's change the polarity. That's 7.22 volts DC. .13 volts. And 1.42 volts DC. I hope that this video has helped you understand the human interface HID device functionality, direct input to spreadsheet function of the DT4261 with the Z3210 wireless adapter. For that matter, direct input to Google Sheets as well. With this capability, one can make spot measurements on a number of test points more efficiently, while keeping an accurate computer record at the same time, right there on site. And this applies not just to the DT4261, but for other wireless Hioki devices. But there's one thing you need to know. Data input to spreadsheet may not be that consistent across all devices. Let me show you. In my smartphone, for example, watch how data entry and transfer behaves between Excel and Google Sheets. Right now, Microsoft Excel app is opened, and I will transfer the value here on the screen. Now, Microsoft Excel app in my smartphone aligns the values perfectly. In this very same smartphone, Google Sheets app is now open. Watch how it transfers and aligns the data. The cursor rests not on the next line, but below the last value there, below the last column value. So when I press the next hold button, it just enters the value out of alignment. So in my smartphone, the Microsoft Excel app aligns the values perfectly, while Google Sheets misaligns them. The takeaway from this is that I may have missed certain settings, granted user shortcomings on my part. But the most important thing is, test first which spreadsheet works with your mobile device, smartphone, tablet, laptop, or desktop computer, and stick with it. So that's the human interface device functionality, direct input to Excel, feature of the DT4261 paired with the Z3210 Wireless Adapter. Both of these devices were made in Japan and carry with them a 3-year warranty from the manufacturer. If you have any comments or suggestions, please let me know in the comments section below. Thank you for watching.